My name is Syed. I'm part of Group 12 for Senior Design 2, and in my group we have Michael Perez, James Luong, Quentin Thomson, and Bryce, Shannon. And our project was the smart outdoor chair. So essentially what we wanted to do, we wanted to protect our outdoor furniture or chair from water damage. So to do this, we embedded water sensors into the frame. So when it does detect rain or water or moisture, the couch closes up into itself and essentially making it waterproof. So these are some of the designs we came up with to model our project on. So we have our sensors on the handrest of the couch, and so when water lands on it, the couch is able to transform and close up into itself. So essentially how we wanted to run our program was it would be running through a constant loop, and when the sensors detect water, then it checks if it's in the couch is in the open position or in the closed position. And if it detects water and it's in the open position, then what happens is the bottom portion of the chair comes down and the top portion folds on top of it. And once the sensor is dry, then it checks if the sensor was in the closed position or open position. And if it's in the closed position and the sensor becomes dry, then the back piece comes up and the bottom piece goes up into its original state, going into the open position. So we'll run through a demonstration and show you how our project works.
As you can see here, we have embedded the 4 water sensors into the frame of our couch. Syed now applies a droplet of water to the water sensor. As you can see, our couch is in an open position. Once this water is detected, our couch will go through a 40-second delay to allow any person sitting on the couch to safely remove themselves. Now this 40-second delay has been sped up for demonstration purposes. After the delay, the bottom portion of the couch will shift downwards due to the actuators, and the back frame, being controlled by the servo motors, will fold over on top. Now that our couch is in a fully closed position, Syed will dry the water off of the sensor to indicate to our couch that there is no more rainfall occurring in the environment. In a real-life example, this would happen when sunlight absorbs the water from our sensor to indicate to our couch that it is now time to go back to its original settings. Once again, our couch will go through a 40-second delay, which is sped up in this demonstration. After the delay takes place, our couch's back frame will come back up from the servo motors and allow the actuators to push the bottom frame back up to its original placement.
Some of the things we want to improve for the future was to use better material and more rigid material for the frame itself. So the whole frame itself, it is waterproof. And we also want to have a better concealing system so water doesn't go through the cracks of the couches. And the way we were planning on doing this was to add magnetic rubber lining on the side. So like when the couch closes, the magnets are able to like push against the cracks, essentially closing it up. We also wanted to have a pressure sensor in the couch, so like if a person is sitting on it and the couch detects water, the couch won't just close up while the person is sitting there. And we were going to have an LCD screen that's able to tell the instructor, the user to get up from the couch. And we wanted to also have a push button so you're able to open and close the couch manually.